Hope everyone had a great weekend. Oh, I sure did. Okay. So, jumping back to our matrix stuff. So last time we talked about learning kind of what the row operations are and how they work and what the notation is for them. So let's go ahead and kind of kick back to that. So we have our starting matrix here. 3, 5, -3, 2, -1, -3, -4, 4, 12. All right, and we want to go through the operations in the specific order. Okay, so first operation, -1/4 times row 3. Okay, so remember when I see multiplying by this fraction of 1/4, people get freaked out about multiplying by fractions. Okay, but it's not a big deal. And for a nice fraction like this, where it's just 1 in the numerator, basically what this means is we're just dividing by -4. Okay, so I'm going to say, all right, so this operation I'm using, I'm doing just copying that down. So row 1 stays exactly the same. Row 2 stays exactly the same. Now row 3 is what gets multiplied by -1/4, or the easier way to think about it is probably divide by -4. -4 divided by -4, 1. 4 divided by -4, -1. 12 divided by -4, -3. Right, so there's the first operation. Second operation is that we're going to swap row 1 and row 3. And we don't change them any other way, like the actual numbers stay the same. They just move places. So now row 3 becomes row 1. So, oops. So now we're looking at this matrix. So I'm going to change row 1 and row 3. So now row 1 is 1, -1, -3. Row 3 is now 3, 5, -3. Okay, so we can see this stuff is now the same, but it's just down here. This stuff is still the same, but just now it's up here. And row 2, 2, -1, -3 stays exactly the same. Right, no trickery there. All right, and lastly, we have our next row operation was, what was it? -2 row 1 plus row 2. Okay. -2 times row 1 plus row 2. So, one of the things that we mentioned, I tried to emphasize, in this notation, this first row, both of these rows do not change. Okay, this first row, or the first row that's listed here, which in this case turns out to be row 1, should stay exactly how it is. So row 1 was this, so it's going to stay that 1. Oops, I don't want to use red. Let's use purple. 1, -1, -3. This does not even list row 3 as anything, so I'm going to go ahead and actually put row 3 in here as well, because that also just stays the same. 3, 5, -3. Right? Because the only thing that's really changing is row 2. Right? We always know when we see this notation, the second row that's listed is the one that changes. All right, so let's back up here. So -2 times row 1. So that would be -2 times 1 plus 2. So -2 plus 2 would be 0. -2 times -1, positive 2. Positive 2 plus -1 is 1. -2 times -3 is positive 6. 6 plus -3 is 3. Right, so there's what my second row now looks like. And again, reminder for the actual PFA or AFA, it won't ask you just to find the final matrix. Instead, it'll say something like, what is A23? Okay, so you still have to go through and do the operations, do whatever it asks you to do, but then once you're done, we want to look for what is the A23 entry. All right, what is the number that's in this spot? So remember, first number is row, second number is column. All right, so the second row, right, so this way, and then the third column. So that means this is 3. So A23 is 3. Okay, or it could ask anything. This part is just random. It's just me deciding I'm going to ask for one of these spots. Who knows which one? All right, row operations. So we're going to do a lot more with these today. But let's first talk about an augmented matrix. So this is a way of writing a system of equations as a matrix. We've actually sort of done this before when I taught you guys how to solve a system of equations using like the TI-84 graphing calculator. So really it's just taking the coefficients, right? 3, -5, 2, -12. Listing them all out, 8, 2, 9, 7. And putting them in a matrix. And the only difference is, just to kind of separate and keep specific like what is on the other side of the equals sign, we can put this kind of like little vertical bar, this vertical line here. Right, so this is an augmented matrix. Right, and this just tells us, this little vertical line just tells us, hey, that means that this represents a system of equations, because it doesn't always have to. A matrix doesn't always have to represent a system of equations, like specifically. But this vertical bar tells us, okay, yeah, all this stuff on the left side is like the actual equation part. This is the equal sign, and this is whatever number's on the other side of that equation. Okay, so nothing tricky. Augmented matrix. All right, so we have a couple forms to talk about. So first of all, we have row echelon form. What row echelon form is, now there's kind of a lot of details with these definitions, but I'm going to simplify them down a little bit, is the entries in the main diagonal are all 1, at least for the matrices that we talk about. Entries in the main diagonal are all 1. Everything below the main diagonal is 0. So what does that mean? Let me show you. So let's make a matrix. Okay, so main diagonal is 1. Okay, we can see that here. Main diagonal, all 1. And everything below is 0. 0, 0, 0. Right, there's nothing below this one, but if there were, it would be 0. Okay, or same thing here. Let's say 1, -2, 4, -6. 0, 1, 3, 100, 0, 0, 1, -6 again, 2, 0, 0, 1. Okay, another just random matrix I made up. So same thing, main diagonal, all 1. Everything below it is 0, 0, 0, 0, 0, 0, 0. Okay, so row echelon form. All right, now to go not one step further, but kind of to go a little more specific, we also have what's called reduced row echelon form. So something you might notice, reduced row echelon form. You'll see this RREF, like the stream title, RREF. All right, and another reason you might recognize this, let me pull up this. If I pull up my wonderful calculator, if you remember when we solved systems of equations, we would go to matrix, math, and we would scroll all the way down to, what was it? That's right, RREF. Okay, so now what we know that stands for now, reduce row echelon form. So first off, that's the same rules as above, right? Where main diagonal is 1, everything below the main diagonal is 0. But now the difference is everything above the main diagonal is also 0. Okay, so if you remember what our answers looked like from when we would solve those systems of equations, we would end up with a matrix that looks like this. Right, so we have our zeros here, right? But instead of having numbers up here, right, everything above is also 0. So 0, 0, 0. Okay, main diagonal is 1. Everything below is 0. Everything above is 0. So, or it could also look like this if we're talking about having an augmented matrix. Right, and this is what our answers end up looking like whenever we would do that on the calculator. And from here, we knew that this meant like, oh, x equals -7, y equals 6, and z equals 2. Okay, so that's why we like putting things in reduced row echelon form, because we can automatically determine what the variables were for the systems of equations. All right. So next up, and there's kind of a lot of long definitions and explanations here. Gaussian elimination or Gauss-Jordan elimination. So what is the difference? Gaussian elimination will get you to row echelon form, right? One of these matrices where there's still actually numbers here above. But Gauss-Jordan elimination, right? Gauss got that far. Gauss was like, this mathematician named Gauss. He was like, yo, we should put this in a row echelon form. That'd be so cool. We could solve the matrix. And that was fine for a while. But then this other guy, Jordan, he was like, yo, wait a minute. What if we made everything above the 1 0 as well? That'd be kind of cool. So Gauss-Jordan elimination will get us all the way to reduce row echelon form, which, again, the difference is reduced row echelon form has the zeros above as well. Right? Mind-blowing. Okay, so here's our steps that we're going to go through. It's kind of long to look at. I hate typing out all these steps like this because I get that it's like, what am I looking at? But as you're going through and solving, at least once we see examples and we kind of understand what this looks like, do refer back to this and so that you're realizing what happens. So get a 1 in the A11 entry, right? So that's that first number in the matrix altogether, right? That top left. Clear all entries below it. So whenever I say clear, I mean make 0. right? So we're getting a 1 in that first spot, right? That's what this first step is, and then clear everything. So I want to get a 0 here and a 0 here. All right, that's my goal. Okay, after that, get a 1 in the A22 entry. All right, so that would be A22s right there. Clear all entries below it. Okay, again, make 0. So then make that a 0. And then continue as needed. So we're also would want to get a 1 down here. That would complete the diagonal. We're mostly going to do 3x3 systems, but we could do however many. We could have 100 rows, and so we'd have to get, you know, however many 1s along the main diagonal, and then getting 0s below it by clearing. All right, so at this point, after we do these 3 steps, our matrix is now in row echelon form. So we have main diagonal, 0s below it. So that's row echelon. We'll still have numbers up here. Who knows what they are? Okay, so now we have row echelon form. So now we're going to use that 1 in the last column to clear everything above it. All right, so our first steps were sort of moving left to right, where we get a 1 here on the far left, and then we move over to the right one, we get a 1 here, and then clear, and then we move over to the right one, we get a 1 here. All right, so now we're going to work our way backwards from right to left. So from right to left, we use the 1 in the right column to get a 0 here and a 0 here. All right, that's clear everything above it. So then we move over to the next to last column, so we just move 1 spot to the left, and we clear everything above that. Okay, so we get a 0 here. Again, continue as needed until you reach RREF, reduced row echelon form. Okay, because we don't know how many rows or how many columns we'll have, but we do it as much as we need to. Right. And then once we've done this, again, that's the form that we like. That's like what we get from our calculator, that we can automatically then say we know what our answers are. Okay. So today we're just going to start by doing kind of shorter versions. All right, we're just going to start with 2x2 systems just to get the hang of it. All right, and then tomorrow we'll move on, or next time we'll move on to larger systems. All right, use Gauss-Jordan elimination to solve the systems of equations. Okay, so first up, I just want to create the matrix. All right, so my augmented matrix is -2, -7, -5, 1, 5, 7. Okay. Oops. Let me put my line here. Remember that just represents like the equal sign. So we're trying to put this stuff on the left here into reduced row echelon form, RREF. And we want to use our matrix operations to get there. Okay, we want to use the matrix operations. So we can use anything we want. Remember, we have swap, interchange any 2 rows, right? Just switch them. We can multiply any row by some number, any number, or fraction, so we can divide. Or third, we can add multiples of 1 row to another row. Okay, so when I look at this matrix, the first thing I see is, well, I have a 1 right here. I really want the 1. My first step is to get a 1 here, but I don't. I have a 1 down here. Well, that's fine. Great. So my first row operation is that I'm just going to switch row 1 and row 2. So 1, 5, 7, -2, -7, -5. Easy. Okay, because my first step is get a 1 in the A11 entry. Great, I did it. There's a 1 here now. All I had to do was switch rows. Okay, and look for easy switches like that. If you already have a 1 in the correct column, but you just need it to be moved up or down, you can move it up or down. Swap rows. Okay? So now I need to make this, I want to clear everything below the 1. So I need to make this -2, 0. Okay, so I don't want to just multiply by 0 on the second row, because then multiplying by 0 is kind of just like a bomb. Like it blows up the whole row, right? I don't want to just, again, if I multiply everything by 0, I just lose all of those numbers. I lose all that information. So I don't want to just multiply by 0. So instead I'm going to use my third row operation of multiply a multiple of the one row by another. Right? So I'm going to take something times row 1 and add it to row 2. So what do I use? Well, what times 1, if I added to -2, would make 0? Well, what do I need to add to -2 to make 0? 2, right? 2 plus -2 is 0. So how can I get 2 from 1? Well, I'll multiply it by 2. So I'm going to do 2 times row 1 plus row 2. Right? And I chose +2 so that it will offset with the -2 and get 0. It's like when we solve systems of equations, right? Like if I wanted to get rid of the x here, I would need to get this one to be 2, +2 and -2, so when I add the equations together, it'll be 0. It's basically the same thing. Right? We're kind of just doing those steps, but in a matrix. Okay, so first row will stay the same. 1, 5, 7. All right, 2 times row 1 plus row 2. So 1 times 2 is 2. 2 plus -2 is 0. 5 times 2 is 10. 10 plus -7 is 3. 7 times 2 is 14. 14 plus -5 is 9. Okay, so I got the 1 in the first column, and I cleared everything below it. Oops, wrong way. So get a 1 in the first column, clear everything below it, done, done. Okay, so next up is I want to get a 1 in the A22, so that next diagonal. So now I want to make this 3. I want to turn it into a 1. Okay, well, I don't want to do any row switching because that would ruin my nice 0 here. And I don't have a 1 up here anyways. So I need to use one of my other 2 row operations to make this a 1. So a really great one is I noticed 3 and 9 are both divisible by 3. So I'm just going to do 1/3 times row 2. So row 1 will stay the same. Row 2 times 1/3, 0 times 1/3 is 0. 3 divided by 3 is 1. 9 divided by 3 is 3. So get a 1 in the A22 entry, done. So now I want to work backwards, right? I moved left to right, now I'm going to move right to left, now that I'm trying to clear the above stuff. So clear all entries. All right, below it, oops, there's nothing below this now. Keep going the wrong way. All right, there's nothing below this 1, so right now I have row echelon form. Right, this matrix is row echelon form, so now I want to get it into reduced row echelon form. So now I want to work right to left, clearing the above stuff. Well, in this case, the matrix is small, so this is the only above thing we have, the 5. So again, if I have +5 and I want to make it 0, Well, what can I add to positive 5 to make 0? Negative 5. All right, and I have a 1 here, so that's really easy to use. So negative 5 R2 plus R1. Row 2 stays the same. 0, 1, 3. Now negative 5. So negative 5 times 0 plus negative 5 times 0 is 0. 0 plus 1 is 1. Okay, so that part just stays 1. Which is good because remember we need this to stay 1 throughout. So moving over, negative 5 times 1, negative 5. Negative 5 plus 5 is 0. Negative 5 times 3 is negative 15. Negative 15 plus 7. Negative 8. Okay, so now this is in reduced row echelon form. We did it. And once we have a matrix that's in reduced row echelon form, we can automatically then know what the answer is. Right? So this first number represents the x value. So x is negative 8. Y is 3. So negative 8, positive 3. Is my answer. Right, so it's just a tedious process. Okay, even though this was a very small matrix, right? This is a 2 by 2 system, 2 equations and 2 variables. It still kind of takes a bit of work to get there. And same thing with solving systems of equations. There's just so many tiny steps where we can go wrong, right? Can really mess things up. So just be super careful. But let's try another example. Use Gauss-Jordan elimination to solve the systems of equations. All right. So first thing we do is just create an augmented matrix that represents the system. So just look at the coefficients, negative 7, 4, 24, 4, negative 4, 0. Okay, so my first overall goal is get a 1 here. And that doesn't necessarily mean make the negative 7 into a 1. It just means do something, do some row operations so that at the end of them there's a 1 here. Okay, so last problem we just had a 1 down here, so we just switched the rows so that there was a 1 up there. So I can't quite do that because I don't have a 1 down here or here. Okay, but I'm looking at this second row, 4, negative 4, 0. I can easily divide this second row by 4 and still have, whole numbers. So you can divide at any step, but the problem is if I just wanted to divide this first row by negative 7, so negative 7 divided by negative 7 would make a 1 here. That's great. But then I would have 4 over 7 and 24 over 7. And as I'm going through doing the rest of my math for the matrix for the row operations, having 4/7 and 24/7 probably isn't the greatest thing to have, right? It would probably make my math a little ugly. So, but if we see that an entire row is divisible by some number, it's probably a good bet to go ahead and divide by that number. Okay, and that especially helps us here. So row 2, I'm going to divide by 4. So row 1 stays the same. 4 divided by 4 is 1. Negative 4 divided by 4 is negative 1. 0 divided by 4 is 0. Now I have a 1 right here, but I want it to be up in that first spot. So great, let's just swap. Swap row 2 and row 1. So 1, negative 1, 0, negative 7, 4, 24. So I have my 1. Next up is to clear the stuff below it. So I want to somehow, I need to get rid of the, or not get rid of, but I need to make the negative 7 into a 0. All right, so this is where, whenever we are making something 0, this is when we're going to want to use our multiply, or add a multiple of one row to another row. All right, and that's why we like to get a 1 here, because it's really easy then to multiply this by something and add it to this to get 0. So when I ask myself, what would I add to negative 7 to make 0? Well, I'd add 7. Great. So I'm going to do 7 times row 1 plus row 2. So row 1 is going to stay the same, but row 2 will change. So 7 times 1 is 7. 7 plus negative 7 is 0. 7 times negative 1 is negative 7. Negative 7 plus 4 is negative 3. 7 times 0 is 0. 0 plus 24 is 24. All right, now my goal is to make this a 1. All right, well, how am I going to make it a 1? Well, look. Again, I'm seeing this entire row, 0, well, 0 I can divide by anything, but negative 3 and 24, they're both divisible by 3. So that'd be really easy then to make this into a 1. I'm going to multiply not just by 1/3, but since this is negative 3, by negative 1/3, so that this will turn into positive 1. Okay, so negative 1/3 times row 2. Row 1 stays as it is. 0 times negative 1/3 is 0. Negative 3 divided by negative 3 is positive 1. 24 divided by negative 3 is negative 8. All right, so this is now just REF, row echelon form, right? Gaussian elimination, but we want to go all the way to reduced row echelon form, do the full Gauss-Jordan process. So that means we need to also make this a 0. But that'll be easy because we have a 1 down here. All right, so what do I need to add to negative 1 to make 0? Just 1. So I'm just going to do row 2 plus row 1. I don't even need to multiply it by anything because I already have 1 and negative 1. All right, so 0 plus 1 is 1. 1 plus negative 1, 0. Negative 8 plus 0 is negative 8. And then row 2 just stays the same. Remember, in this format, whatever the first row that you list here is stays the same. 0, 1. So look at, I have main diagonal is 1s, 0 below, 0 above. So this is reduced row echelon form. So from here I can just determine that x equals -8, and for this problem they're the same. X is -8 and y is -8. So my solution would be the point -8, -8. So there's two more. I think there's two more. Yeah, there's two more. I would love for you to take those and practice those on your own. Again, they're just the 2x2 system, so just getting a hang of using the row operations to get to reduced row echelon form. So we did R2. So yeah, my homework for you would be to practice these two. Right? It does take practice to get used to this because it's weird. It's really easy to make mistakes, so triple check your work at every step, because otherwise you're going to go through and do something and then realize 12 steps later that you made a mistake in the very first step. Okay, trust me, I've done it plenty of times. You can ask my college algebra students from last year. They did it plenty of times. Okay, so check your work as much as you can. Otherwise it'll eat you alive. So yeah, that's it here. Next time when we come back, we'll move to a bigger system. So we'll do kind of like a 3x3 system, maybe even a 4x4 system. That would be pretty intense. Yeah. Any questions or anything? Guess not. Is that it for matrices? No. No. We have much more. I think for matrices, like the PFA or the AFA, or both. We probably have well, hold on. Let me look at the objectives for each, because I forget which falls into which. I know it's definitely not the it. But let me look to see when. Okay. Matrices. Scalar multiplication. Matrix multiplication. No, so for matrices, we still have a little bit. We have one more objective for the PFA, which is finding the determinant and inverse of 2x2. So that'll be probably maybe Friday that we'll get to that, maybe. Depends on how fast the stuff goes next time. Friday or Tuesday will be when we get to that. It's objective 5. There's a lot of objectives in this matrix PFA. It's objective 5, but it's a quick objective though. Honestly, Jacob, like this, not even me saying this as a math teacher, but objective 5 is you could do that on your own pretty quickly if you just wanted to go through and look at like a couple of the videos or something. It's not difficult. It's like a rule that you have to memorize, but then that's it. So you could check that out if you want, or you could wait. It'll probably be Friday or Tuesday that we get to that in class. But if you have time, it won't take you very long. Otherwise, the first 4 objectives you have those, or we've talked about them at least. The AFA. What's the AFA? Or the objectives for the AFA? The AFA objectives 3 and 4 won't be for a while. It'll probably be 2 weeks before we get to objective 3 or objective 4, because those are like really like the last things that we learn in this class. So it'll still be a while for those, the AFA ones, but the PFA ones, we'll get to it soon, and or you could take a look at it on your own if you want. All right. Let me know any questions you have. Again, I'd recommend practicing those 2 that are at the end here that we did not do. 1, 2. Just to get a feel for Gauss-Jordan elimination. And then I will see you guys back on Wednesday. Okay. Have a great Monday.